Let's talk about the meaning of exponents and roots. And I'm going to start by explaining the definition of exponents. So an exponent is represented as follows. So if we have a to the b power, which we write like this, that came out a little tiny, we can say a to the power b or a to the b power. And the value of b just tells us how many times to multiply a by itself. And another example to use real numbers is 3 to the second power, or 3 to the power of 2. And that tells us to take 3 and multiply it by itself 2 times, and that gives us 9. A is called the base, and B is called the exponent. And to look at my other example, 3 to the second power, the 3 is called the base, and the smaller 2 is called the exponent. So let's look at some examples. In example A, we have 2 to the third power. So that tells us to take 2 and multiply it by itself 3 times. So 2 times 2 times 2 is 8. Now on the calculator, if you want to have your calculator do the exponent, you just punch in 2, and then you find the exponent key, which looks like it's this arrow pointing up, also called the caret key sometimes, and that will get you into the exponent position, and then you can press 3 and enter, and that gives you 8. Now this next one, sometimes with the negative signs it can be tricky because it depends whether or not there are parentheses around the negative number or not. You're going to get a different answer. So for B, because the parentheses encompass that -2, that tells us to take -2 and multiply it by itself 3 times. -2 is the base. And if we do that, -2 times -2 is 4, times -2 is -8. So the answer is -8. And we can use a calculator. We can use parentheses in the calculator to type it exactly how we see in the problem. And we get -8 using the calculator. Now for part C, there are no parentheses, and so this problem, it's actually like there's a little -1 on the outside times 4 squared. That's essentially what we need to do here. You could also think about the order of operations, which tell us that we have to do exponents first and then multiply, or then apply that negative sign. So what we're going to do here is we're going to do 4 times 4, that's 4 squared is 16, and then that negative sign just stays out front, kind of like we're multiplying by -1, and we get -16. And you can see if we punch that in the calculator like that, so -4 to the second power, we get -16. But notice if I put parentheses and put the negative inside the parentheses, then I get +16. So you have to really just pay attention to what the problem's asking you to do. And then this last one, so we've got some multiplication, so that it's 5 times -3 squared. We always have to do exponents before the multiplication. So we're going to do -3 squared first. So we're going to do -3 times -3, because that negative is inside the parentheses, and we get 9. And then we're going to do 5 times 9. So this is first, and then we multiply by 5 is going to be our second step. So 5 times 9 is 45. You could also put in the calculator to double check. So you'll enter it just like it is written there, -3, and then to the second power, we end up getting a +45. So let's talk a little bit about perfect squares and related square roots, because when we're dealing with exponents, exponents and square roots go hand in hand, because square roots undo exponents. And so sometimes it's helpful also to talk about perfect squares, because those make really nice square roots that we can do by hand. So remember that squaring a value means to raise to the second power or multiply by itself. Perfect squares are the result when we square a whole number. So let's look at this table. We're going to first look at the first column of this table down here. So if we think about whole numbers, the first whole number is 0. So what do we get when we square 0? 0 times 0 just gives us 0. 1 squared is 1 times 1. We get 1. 2 squared is 2 times 2. We get 4. 3 squared is 9. 4 squared is 16. 5 times 5 is 25. And we could keep on going. Well, when we take the square root of what we call a perfect square, watch what happens. We get a nice answer. So the square root of 0 just asks us Well, what times itself gives us the number underneath. So what times what gives us 0? 0 does. What times what gives us 1? 1. The square root of 4, we can say what times itself gives us 4? Well, the number 2 times itself gives us 4. So the answer here is 2. The square root of 9 is 3 because 3 times 3 gives us 9. Square root of 16 is 4. The square root of 25 is 5 since 5 times 5 gives us 25. So notice that whenever you, when the value under the square root is a perfect square, such as 0, 1, 4, 9, 16, 25, then we end up getting a really nice square root where our answer is a whole number. Many times, though, your answer is not going to be a whole number. You're not going to be taking the square root of a perfect square. So what do you do in that case? Well, in that case, we're going to use our calculator. So let's talk about how we can use our calculator when we find a square root. So the square root button on the TI-34 is right here. So it's above the 7 key. And then let me show you what it looks like on the graphing calculator. So on this calculator, the square root button is actually above the x squared key. So you have to press second and then x squared, and then the square root symbol pops up. And so if I just type in 12 to do A, I get the square root of 12. And we're going to round to the hundredth place. So this answer would be 3.46. And then on a TI-30 or 34, you just press the square root button and then 12, and you get the same thing. And so let's try the second one. So square root of 26. So square root button, 26. We're going to round to the hundredth place. So we get 5 point. In this case, we have 0.99. So the hundredth place, we're going to need to bump that up. So it's going to be 5.10 or 5.1 since that 9, that 0.9 needs to move up essentially to like a 10. So 5.1 or 5.10 is going to be our answer there. And then we've got square root of 4, which is just 2. So we don't need a calculator there since 2 times 2 is 4. And then this last one, so what's the square root of -4? So that's asking what number times itself equals -4. The problem with this question is, well, if we think about the rules of multiplying negative numbers, when you have a negative times a negative number, you get a positive answer. If you have a positive number times a positive number, you end up getting a positive answer. So there is no situation where you would have a number times itself and get a negative answer. So this is impossible. It's not a real number is another way to say it. If you ever forget, you can always have your calculator try to do it. So watch what happens if I try to take the square root of -4, you get a domain error, and I can show you on the graphing calculator if we do that. So it gives us a different answer. It says non-real answer, but still either way, regardless of what calculator you have, it'll give you some sort of error. So it is not possible to take the square root of a negative number.